Hey everyone, Blockchain Bernie here with our latest episode about parallelization in blockchain and a parallel runtime in smart contracts. Why is that important? We want those blockchains performant. They need to be fast and transaction fees need to be low, and we need to have lots of block space, which is the scarce resource that drives the transaction fees up. So if we don't have a lot of block space, the fees won't be low. We need to have these blockchains fast and cheap in order to get mass adoption. And only with mass adoption, blockchain is going to do the good to society that it's being designed for. We need mass adoption, and there's simply no mass adoption without performance. So it's as simple as that. So that's why we need a parallel runtime. And parallel runtime means that the validators, thousands of validators that are out there for many of the smart contract blockchains, including Solana, which I'm talking about today, the validators need to replay all the smart contracts in order to, cast their vote if everything was okay. And they need to do that replay, and they need to do it fast. And the block producer needs to run the smart contracts fast also in order to produce the block fast. So, and if that is all sequential and, we can only access one account after the other, the performance will be really low. So what we want is a runtime where we can parallelize things. But we cannot parallelize everything. We might have data dependencies, right? And the thing is, smart contracts in Solana cannot just have their own local variables or something. Everything you write to is a Solana account. All data that you need to remember, from one transaction to the other, it needs to be in a Solana account. That's a big difference to Solidity, or if you come from EVM or Ethereum compatible blockchains, it's different there. In Solana, it all goes through accounts, and the reason is we can parallelize it, right? And each and every transaction or each and every instruction, which is one more level fine-grained what's inside transactions, it's usually one or more instructions. And all these instructions, they have to declare what accounts they will be reading and what accounts they will be writing to. And with that information, the Solana runtime can do its job of figuring out which of these instructions can run in parallel. If they don't have data dependencies, right? If I say, okay, this instruction is writing to account A, and then we have the next instruction that's reading from account A, well, it has to be in that order, right? Or if we have several writes in order, then it can't be parallelized. But so many instructions and transactions in the world just don't use the same accounts. So they can all be parallelized. And the Solana validators all have at least 16 cores and stuff like that. So they can replay all that stuff in parallel. And the validators, once they are the leaders and they are the block producers, they can create that stuff in parallel also. It just makes programming a little bit more tricky. So the developer has to think each and every time, okay, what am I doing here? What accounts am I reading from? What accounts am I writing from? It makes life a little bit more difficult for the developer. But it's not only to the benefit of the Solana blockchain to be way faster, it's also to the benefit of the programmer themselves, because they can reason about their software better, and they are forced to think about, what am I doing here? Am I reading, writing to that? And it helps, with clear thinking when you write your smart contract. So I personally love this a parallel runtime. Aptos has embraced that as well with their chain that just launched. It's a great innovation, and it makes blockchain fast. And the Bitoku blockchain that we are building, the storage layer for Solana, will borrow a lot of these concepts from Solana, right? So we will have the proof of history as well. We have the parallel runtime as well, because also the Bitoku chain, the storage layer, needs to be fast. Some other storage chains are really, really slow and costly and things like that, right? So by borrowing these Solana concepts, we will have the fastest storage blockchain in the world, and it will interact with Solana so that Solana programmers that build smart contracts, that they can just use our SDK and write programs that have storage, write programs that can open a large file and write data to it, and then, read another file and stuff like that. And these huge files are not stored on the Solana blockchain because it would be too expensive for each validator to have terabytes of data or exabytes or whatever for each and every Solana validator. It has to be on separate storage provider nodes, right? And then the programmer chooses like, oh, I want to have it on 7 storage providers or on 23 or whatever, right? Some number that you feel comfortable with, to have the level of redundancy and censorship resistance and everything that you want. And it's not that we only have the storage providers in the Bitoku chain, we also have the validators that you can be part of. Go to bitoku.io to secure your right to run a validator in the Bitoku chain, which is the storage layer for Solana. Thanks for watching. Catch you later. Bye.